Okay, so in this example, we are talking about inverse variation, which is a relation that can be modeled by the equation y equals k over x, where xy equals k, and k represents the constant of variation. So once you find that constant, it's true for the same situation and can be used over and over again. And in this example that we're going to do, we are on a trip to Gotham. The rate traveled varies inversely to the time it takes. If it takes 3 hours to take the trip at 75 miles per hour, how long will it take if you travel at 60 miles per hour? So going through this, there's usually 3 phases to variation problems. The first phase being find the value for k. The second phase is to, after finding the value for k, write the equation. And the third phase is to actually use that equation. Now, many variation problems in math will ask you for one of those 3 stages. So sometimes, depending on what the question is asking, you don't have to do all the stages. In order to find k, we need the basic equation and a completed set of information. So I like to change my variables because it helps me keep track of what's what in word problems. If I read it again, it says the rate traveled varies inversely to the time it takes. So that tells me my variables are rate and the time it takes. So I'm going to change my x's and y's to r's and t's. And usually when you set up a variation problem, they go, the order the variable comes in is exactly how you read it, in the exact same order. For inverse variation, though, it's very forgiving. Even if you were to use the wrong thing for the wrong variable, it doesn't really matter. So I'm going to use the second format and change it to r times t, rate times time, equals k. Now, the completed set of information that I have here takes 3 hours to take the trip at 75 miles per hour. We have both the time and the rate. So that is my completed set of information. So rate is 75 miles per hour. Time is 3 hours. K is k. 3 times 75 is 225. And that's equal to k. So phase 1 done. Phase 2 is to write the equation. So we have r times t. When you write the equation, you're just filling in k. And k we found to be 225. The last phase is to use the equation to solve the problem. If you look, we're asked how long will the trip take if you travel at 60 miles per hour. So now we're going to use our equation. We'll replace the rate with 60. Our time is t, that's what we're looking for. And we're still equal to our k, which is 225. If we go to solve this for t, we'll divide both sides by 60. We get that t is equal to 3.75 hours. Since our time was measured in hours in the beginning information, it's still measured in hours here. And if you want, you can also turn that into actual what normal people use and say 3 hours and 45 minutes, 45 minutes, if you are curious about it. That's it.